messed up now in math class.
Taught you wrong, it's on the internet forever.
Yeah.
I'm sure somebody's gonna comment on it then. It's gonna happen.
You're gonna take it off.
Yeah, I don't care too.
Just like take a video after school of you teaching it to no one.
I've done that before when I forgot to record. Like I'm like in here by myself, or I'm on an iPad just doing it by myself and screen record.
I'm like, get off your phone.
I've done that. 'Cause that's the one video like I didn't record, so that would be the one video like 10 kids need to see it again. All right. So, all right. We're gonna start with cube rule. The cube rule, yesterday we talked about this. The rule was it has to be a binomial. We talked about that. It can be anything. It can be a sum or difference. That's the difference between a difference of squares and cube rule. Cube rule can be plus or minus, but it has to be a binomial. The numbers have to be cube numbers. So, cube leading coefficients. And we went through that list yesterday. So make sure that you have that cube list, because we're going to use that today. That'll kind of identify stuff. And then the variables have to be multiples of 3. Multiples of 3. These are the basic things. You just have to see that it does fit the stipulation so that you can do the cube rule. I'm going to do one cube rule right away to get you kind of back in the flow of things, and then we're going to do a difference of squares. And I want to compare, like, because there's that one problem that exists that you could actually have a cube rule, or it could be a difference of squares. It's like either or. Because of the numbers that are involved. Because if you have multiples of 3 for variables, you have a potential where one of the multiples can be even, like a power of 6 or a power of 12. That's also a multiple of 3. And cube numbers, there is one particular cube number that's also a perfect square, and that's the number 64. Now there's obviously more than that, but the first one I can think of is 64. Well, if 64 is a perfect square and a cube rule, that means you could do it either way. So we'll look at that one later. But let's jump right in. Let's pick a cube root number. So we're gonna go. Let's go with like 8x cubed. We're gonna subtract 343, and I'm gonna put a y to the. Let's go y to the 6th power. Just kind of change it up here. We'll do 2 variables. Okay. By looking at the numbers, you can definitely see that this is. That this particular problem is it is a cube rule, because the powers are multiples of 3. The numbers out front are cube numbers. So 8 is 2 times 2 times 2. 343, I believe, is 7 times 7 times 7. And so the rule is you have to have a small parenthesis and a large parenthesis. So it's got to be a binomial here. In fact, I'm going to write that. This has to be a binomial first. And then you have to have a trinomial in the back. Now, why I'm taking the time today to talk about this again. This is one I'm always worried about. It's one rule that people, it's difficult. It's more difficult, I think, than the other ones. But I always get that one person that thinks when you do a trinomial, that you do this. That's not how you do trinomials. You don't just do 3 parentheses. It's not how it works. So, it's a small parenthesis and a big parenthesis. That's the rule. Okay, so binomial. In the front, how this works is that the symbol that's in this first parenthesis has to be whatever's sitting here. So whatever your problem is, that minus sign, I guess, in yours, it's going to go in the first parenthesis. It's guaranteed. If it's a plus, it goes a plus in the first one. The symbol that's in the back, the one that comes right after it, because this is a trinomial, so there'll be 3 items in here, so there'll be 2 symbols separating the 3 parts. The next symbol is going to be the exact opposite of it. So if it was a minus in the front, there's a plus next. And then the symbol in the very, very back has to always be a plus, no matter what. So the acronym we used yesterday was called SOAP. Same, opposite, always positive. So it's SOAP. That's a little acronym. I think your book even has it printed like in the little margins when you actually look at this stuff. Okay, now, to get the first parenthesis, that binomial, that's the most important thing you could be doing. You have to guarantee that you get those numbers first, because the first parenthesis here, whatever these 2 numbers are, or variables, whatever they're going to be, that makes up the back parenthesis. And so it's important you get the first one. So to get this, you just have to take the cube root of these items. So what I mean by that is that you're literally taking the cube root of 8x to the 3rd. That's what you're doing. So what's the cube root of 8? 2. And what's the cube root of x to the 3rd? X. You're trying to think of like what item multiplies on itself 3 times, it gives you the 8x to the third. For variables, the easiest thing to do is just divide by the power. Divide by the 3, the index number. So it's 2 to the x, right? Then the second part here, same thing. We're gonna take the cube root of 343y to the 6th. So again, the cube root of 343, 7. Again, you'd have to actually kind of look at the list. I think I made the list yesterday for you guys up through 7. I think 8 is like 512 or something like that. I don't exactly know. I think it's that. But you can keep going from there. Now for the variable, y to the 6, and we're going to take the cube root of it. So you take the power of 6 and divide by the index number. So what's 6 divided by 3? 2 y to the 2nd. That's how it works. That's how you take cube roots. That's how you take cube roots of variables really, really quickly. Okay. Questions at all about the first parenthesis? How I got it? How it works? Okay. Now that you have that one, then in the back, we're just using the 2x and the 7y to the 2nd, and that's what's going to make up everything in the back. So, to find the first item, this item right here, you're going to square this item. So you're going to put the power of 2, square it, on both the 2 and the x. So 2x squared is 4x to the 2nd. That's just how it works. So you square the first item. The back item, the one that's way, way back here, is the square of the back item. So now you're going to square both of these. You're going to square the 7 and the y squared. What do you get? You square them.
49y to the 4th.
49y to the 4th. Perfect. Okay. Makes sense? How you square them? The middle item is just take this parenthesis, and multiply these two parts together. Don't worry about the sign in the middle. I don't care about the sign. We already took care of all the signs earlier. But you're going to take the 2x and the 7y to the 2nd and multiply them together. So I get 14xy to the 2nd. Just multiply them, whatever they are. That first parenthesis gave you everything in the back by just using it. And that's your answer. This is what I'm looking for. This is the factored form of the cube problem. It's the factored form. It broke it up. It won't go any further. I know the back looks like a trinomial. If you do this process correctly, there is no way you're going to be able to break up the 4 and the 49 in that back if you want to try to do like a trinomial rule to make 14 here. It's not possible. It won't work. It doesn't work that way. And the front shouldn't have anything else, as long as you've already taken out common factors and stuff. But there's a rare case where it could, and we'll see that later. That's that one rare example I want to show you. All right, questions, comments about this problem now? Okay, now, to prove the point that it does work, like this is the answer I'm always looking for. I'm looking for you to factor. But why does this work? Because when you actually distribute over, like you start multiplying everything back together again, certain items will cancel out, and it's usually all the middle terms. So if, I'm actually going to FOIL this. 2x times everything back there. So 2x times this is 8x to the 3rd. 2x times 14 is 28x squared y squared. 2x times the 49 is 98x y to the 4th. So that's taking the first item times everything in the back. Going to the next item. Negative 7 times the 4 is negative 28 x squared y squared. Negative 7 times 14 is negative 98 x y to the 4th. That's 7 times 14 is negative 98. And then 7 times the 49 in the back is negative 343 y to the 6th. And as you can tell, certain items line up perfectly to cancel out, and you're left with the item that you're starting. It works. It's just the way that it foils together guarantees the process will work. Okay. Is there any questions, comments, concerns about cube rule at all? Like, does anyone need me to do another simple, easy one before we kind of move on to the more difficult stuff? Okay. The difficult problem I want to talk about, it's really not difficult, it's just so different compared to what we're used to. You could have potential to have a cubed root problem, like a cube problem, where you could choose to do difference of squares. And I'm just going to give you one example of this. This, again, there's more than one. I just want to show you this. This problem right here. It could be a difference of squares, or it could be a cube rule. That's the weird issue with this problem. Because it is a difference, it is a binomial, these are perfect squares, there's a 1, there's a 64, and it has an even power. Or if you think about it, that is a cube number, 64 is cubed, 4 times 4 times 4, and that is a multiple of 3 for an x. So it has potential, it can go either way. It's whatever way you want to do it. And that's the weird issue with this problem. That if you choose, like if you looked at that problem and went, oh, that's a difference of squares, you'd be doing your problem like this. You'd be going, okay, difference of squares would be plus minus, right, that's the rule. You break up the x to the 6 evenly, so x to the third, x to the third. You break 64 to be 8 and 8. Okay, you'd be doing that. The issue is, if you did it by difference of squares, do you see what you're left with? You're left with cube rule. This is a cube rule. That's a cube rule. So you could go further. You could go another step here. So even if you chose to do difference of squares first, it ended up being the other one as well. So now, so you did difference of squares. But now you have to do the cube rule. In fact, you have to do the cube rule twice on this problem. Because there is 2 perfect cube numbers. This is a multiple of 3, that is a cube number, multiple of 3 cube number, one's plus, one's minus. So the idea here is that for this parenthesis, I'm just going to do this first one here. I have to do a small parenthesis and a large one. This has to be a binomial and a trinomial. That's just for this piece. Then in the back, this one over here, like this parenthesis, I have to do it again. Small, big. So you have to do everything over again. And so the difference here is that this one has a plus, then it'll be minus plus. Break up the x, break up the 8 to be a 2, square both, multiply them together. There's the first one. And this won't be able to be broken up any further. Back there, doing the difference here, so this would be a minus, so I'll go plus, plus. Break up the x, break up the 8, this would be x squared, 2x, and a 4. And these are all being multiplied together. There's 4 parentheses multiplied together in the end. That's if you chose to do difference of squares first. If you did the cube rule first, what would happen is that you'd be, if you did the cube rule on this, you'd have your 2 parentheses, small and big, and then the small one would be able to be broken up because it would be a difference of squares. So eventually it will work out to be the exact same thing again. The hardest part about choosing to do the cube rule first, doing the cube rule here, if I were to choose that to do it differently, is that the back parenthesis would look almost impossible to factor. But it would, because of this is actually proving the case that it would actually be factorable, that you can go further. So just be aware of that. If you ever have a problem that could go either way, like difference of squares or cube rule, choose difference of squares first, like this. Do it that way first. It makes it easier because the rules are a lot cleaner and the numbers will be smaller, if that makes sense to you. Choose do difference of squares first. That's why I actually did it that way. I don't choose to do it by cube rule first. It makes it a lot more challenging. Questions, comments? Okay, let's talk about grouping method. This is the part where we're going to need some examples from people in the room for grouping. I just want to show you, the start of the problem, like what we're trying to look for, and then I'm going to ask for some volunteers. So it's going to be a problem where there's 4 or more items. So we're going to be in our book, I don't even know what page that is. I'll give you the page number here in a minute. But it'll be an item with 4 things across. Usually this is how it always starts. Where they're being either added or subtracted, but there's 4 items across. The easiest example I can give you for the cube rule, which is the one that I think every textbook always uses as their default example, is something like this. xy plus 8y, right? That's the first part. In the back, they usually have something like 4x plus 16 or something like that. No, let's go 32. This is usually like the default thing that they always do. Like it's the easiest problem in the world. If you look at the problem, you can't add or subtract anything together. So the trick is you group things that look similar. Like for instance, I would group these two together because they both have the letter y on them. I would group these two together in the back because they both have multiples of 4. They have a common factor of 4 in them. You could mix and match. There is a way you can do that. I could have grouped maybe the xy and the 4x together, group the 8y and the 32 together. You can do this different. You can rearrange and choose to do the grouping method different, but your answer in the end will be the same. So if I'm going to choose to pull these together, what I do is I just do a common factor. That's how grouping method works. So what do these two things have in common? A y. You pull a y out. So I'm going to be left with an x plus 8 if I pull a y out from both of those. Notice it has to be a binomial left in the inside because I started with a binomial here. In the back, same thing. I can pull out what they have in common. Well, in the back, they have a 4 in common. So I'm going to pull the 4 out. So I'm going to be left with an x plus 8. And if you do this correctly, what should happen if the grouping process actually works out perfectly is that you should be left with 2 parentheses that look the same. Now I know you did them differently, right? You did 2 separate things at once. You did common factors twice. But what should happen is that the parentheses that are left over should be the same. If they're not the same, you didn't take out the right item. Like you didn't take out a negative sign. That's usually a common mistake. Or maybe you should have taken out like a 2 instead of a 4, so that it guarantees that the 2 parentheses look identical. Okay, because once the parentheses look the same, then you only have one more step. It's basically going reverse distribution, where what I'm going to do is I'm going to look at, now this is going to seem a little odd, I'm going to look at the whole thing, like both items now, and what do both of these things have in common? This green one and the blue one here. What do they share? Well, they have an x plus 8, right? So you're going to rip an x plus 8 off of these 2 items. This is like a binomial. This item plus this item. Well, if I took an x plus 8 out, I'm left with a binomial. The thing that I'm left with, if this x plus 8 went in the back, was a y plus 4. And that's your idea. When you do differences, or when you do a grouping method, it should usually come down to 2 binomials like that, perfectly, every single time. But the process that people get stuck on was just trying to make these parentheses look the same. If they're different, you have to manipulate them. You have to take out a negative sign or switch them around, switch the order. But they have to look identical so that you can take it out in the next step. Does that make sense what a grouping method is? It's by far the most challenging type of factoring because it's way open-ended. Like trinomial rule has set rules, what you look for. Cube rule has a set rule. Different squares has a set rule. Common factors, you're just taking what they have in common, all right? That's not a challenge. This one, it's super open-ended because you just need to make sure, however you group these together to start with, when you pull things out, the parentheses look the same. So it's crazy open-ended. Okay? All right, so let's take out your book. At least one person in your little group, take out a book. Okay? Because we're going to go around the room, we're going to grab some different problems here. To start with, we're going to start with something easy, and we're going to work our way to the more challenging one today. So the goal here today is to do as many problems as we can get done, and we're going to have each group come up here and show their type of problem. Okay? So you're going to be working together as your little pod, your little group. Okay? When we get to these grouping problems, these grouping methods, I'll do the first one. We'll have a group pick out one of them, and then each group in here will do a different one. So the page I'd like you to be on is page 65, please. Turn to 65 in your book. Hopefully everyone's got a textbook. Page 65. All right. Okay, so the first example that I want is that, I'm gonna start with a group up here, so Kenzie and Meg, you guys are my first group. I'd like you guys to pick out a problem from either 1 through 10. 1 through 10. Okay? So you can pick any problem you want, start working on that. Okay, 1 through 10. Okay? Alright, you guys, I want you to pick a problem from 17 through 24. Just pick any problem, one problem, work on it together. Okay? Next group, go 25 through 32. Pick a problem there. That's Sam's group. Okay, Abby, you guys have a problem from 33 to 38. Okay? Alright, Mariah's group back there, you guys can pick a problem from 39 to 48. Okay? Your guys' group is going to pick a problem from 57 through 64. Okay? And the last one here, we're going to pick a problem, any of the problems 65 and on. Okay, I'll be in your group. Okay, pick a problem. Your group is going to work on that one problem. Hopefully you remember the sets I told you you can pick from. Once you have your problem, you both have worked on it, you both feel comfortable, you're going to come up front, you're going to present that problem to the group. And if you want, I'll turn off the camera. Okay, so you're not like stressed out. Okay? Alright, work on it. I'll give you 5 minutes. We're going to try to go through these as quickly as we can. Alright, what do you got? What do you think?
78.
78? Does it have to be that?
Because the first one's usually God, this thing is supposed to be percent. I said that.
Okay. It's not a difficult.
No.
So we keep this that way.
Why?
It is not a huge because the powers. And it's not a football.
I watch your
So back this one.
You don't have black sleeves. But I watched you do it. It was a distraction to show.
You can go.
Really not.
Sometimes it's a trade on the line, so. I think it does. There's no mic sign.
They're thrift shorts, and I made them into shorts.
It's nice to see that. So
$3.
Oh, it's funny.
Look like the $80 ones.
So? Factory's trying to say that I know what.
No, my friend was in the school.
Yeah, I did. I wanted to get started at it.
Patrick's like, do we have to keep that?
did we plug the biggest number?
We're gonna get through lunch, okay?
No,
I think Patrick was.
Now, hey, don't erase, don't erase. Have that one, but then also put down below what the real answer should be. Okay, so like, instead of pulling out 4, you should pull out 8. Put that one down below. The reason why, it's nice to see like your thought process for doing that, because if others see that, they're like, oh, yeah, that makes sense to me too. That's good to show that. Okay, so when you guys present, that's something you should share.
Alright.
I switched it to one.
Just figuring it out.
that's a 3.
This is just my calendar.
Yeah, just doing that.
Same operation, so
There's something you
so we're
probably
gonna be
should have done.
negative.
Oh.
Wait, what am I thinking?
Oh, there's 17 in the middle, so no. There's, I thought that was a
I
little.
know, maybe I want to go outside to pee, because the gym's going to be really hot.
So yeah, it's trying there. You can see it. 5.
I have to work that day tomorrow.
Mr. Ward, I had a
At
quick
1
problem.
o'clock until 10.
Yeah, what's 2x minus 3?
I wanted the 8 o'clock to like 10:45 one, but I was like, get it done, have the rest of my day to do whatever I want to do.
Minus 3.
Because I also was like
2x plus 3
supposed to
minus
work today or
2x
tomorrow.
minus 3 all is 0.
So I'm like, oh, great, now I can't work and make money that I need for pay off my car or whatever, you know?
Anything to zero's power is 1.
She's like, if you can find somebody to work out for you, then go ahead. Nobody's gonna want to do that.
Yeah.
12.
Especially when I gotta pick like
Yeah,
second to
probably. They
last.
tricked
That's the
us.
problem I did
No one's
yesterday.
gonna wanna do that.
Maybe it did work.
Is it literally the problem?
Because you guys get someone to work with.
No.
I think they will.
There we go.
Well, that would make sense, yeah.
I did 4 homeworks last
So we're
night.
just getting another crazy problem.
The 2 that we're doing today,
In a row.
and then, okay, that second one, and then one said that it was due today, but like, I thought it was already late.
You guys got it figured out?
Nope.
No,
So I was
Jordan.
confused.
Because you're.
I did it, cause it said
Give it a
due
couple more
tomorrow,
minutes.
but I didn't last night. So I didn't like screenshot it or anything, but I thought it was already.
Well, I was just like, well, we can't pick the first one because
So I don't know if you want to talk to her about it, cause I don't remember which one it
the
was.
second odd one. So we can check it in the back. We did it right.
Good strategy, that's what I give you
And
options.
then I'm all
See,
caught up.
big options. It's good to pick an
We didn't
option.
even figure this
What
out
happens
because
in the
we're
amount of pages that
supposed
we're
to
supposed to read? I have no idea because I didn't know the amount of pages that were supposed to read, so I didn't read it. I couldn't even look up the summary because I don't know what pages we're supposed to
Because you
read.
know how he said,
Um,
like, just
okay.
you remember it, but it's not blocked, like you can't do it.
Yeah, but we stopped like 5 pages. I don't know.
This looks
Well,
rough.
how can you-
I can click that it's
Keep
not.
working, keep
Spoiling everything for
It's
us
not,
if
it
you
works.
don't read the book. I didn't spoil anything.
I don't remember everything.
I went into your. Everybody literally just made
It's
it
the
up.
first page, is that first number of 6?
I went into your
Yeah.
costume.
Probably go 2 and 3.
Yeah, you did.
The back number's a 5,
Yeah.
Huh?
go
I
5
when
and
you
1.
were in class, I was like, this is.
It matters where you put them,
It's spoiled.
so that you can make it 10 minus 3, or 3 minus
It's
10.
like, I will. I know, it's been a problem.
The B squared.
I really want those water bottles like that, you know, how they put them in the book. They're like $32. Yeah.
Okay.
check it out.
You guys want me to turn off the camera and get some?
We got it.
Yeah. Okay. Alright, okay. Hey, we're gonna have our groups present. I'm gonna turn off the camera. Hopefully no one has a problem with that because I don't want to point out they don't want to be on the camera. So then they're gonna go up to the board. You guys go up, take your problem, take your notebook. I don't care. You're gonna present your problem that you had, show how you did it, and try to walk through the different thing that you found. Okay? Alright, perfect. Here we go.
X squared minus 2x minus 15. You want us to like check the problem too, so like put it back?
No.
Okay.
Because I think everyone will figure it out. Sorry.
So, first, we add our parentheses.
Just like that.
We split up the x.
There's 2 of them.
We did. We split up the 15, the 5, and 3, and then we add negative, positive, 5, 3.
There it is.
Perfect. Now, why does it give you the negative 2 in the middle? Why does it give you the negative 2?
Because if you do your stuff,
Yeah.
it adds up.
To get
If you floor it back out, then you're gonna get x squared, and you're gonna get a 3x, and then you're gonna get a negative 5x, and then that gives you negative 2x, and then you floor that, and then that's negative 15.
Alright, good. Good work. Alright, good work. Next group, would you like to be on camera or no?
I don't care.
Okay, no camera, stay on. Fire away. That was good. Good work, group. Oh, and by the way, group, what type of problem did you guys have? Yep, trinomial. That was a trinomial that they just did. Nicely done. Good work.
I got no problem.
Okay, so, well, I'm just gonna write the answer. You can explain it.
Alright, so you gotta split up the old x squared term, so we did 2x and 3x. And then from there, we just put a whole bunch of different numbers in here that multiply to equal 12. And we knew that they were both negative because this was negative and this was positive. And we got there.
There you go. I think it was the same problem we did yesterday, so I think it was the same one. I just put the numbers in the wrong spot yesterday when I was looking at it. But no, that was good. It works out. Nicely done. What type of problem was it again?
Trinomial.
Trinomial. Alright, very nice. Next group, camera on or off?
Did you figure it
You
out?
can leave it on.
Leave it on. Here we go. Fire away.
Huh?
You figured it out?
You're just reading the whole time. Okay. So, it back so I can see. So, I don't like this one. So that is our problem. And then okay, that was our answer. Any questions?
What type of problem do you have?
Trinomial.
Okay.
Jordan, would you like to explain?
How did you get it that way?
Jordan?
So the 3x and the 2x, multiply it to 6x squared. This is negative 10xy plus 3xy to get negative 7xy, and then minus 5y squared. for the last terms.
I said it. Alright, good work. Next group. Will you guys like camera on or off?
I don't care.
Don't care, so staying on. Here we go.
I like which
Why?
38.
You can check. You probably have.
She's correct.
He said Jordan and Farmer.
I figured that out. I just didn't know.
Oh, I got two groups left. Alright. You guys have way better English than I do. Just sad.
Yeah, when I read like number 5 for the like whatever, I thought it said graphing instead of grouping.
Oh, it does look like graphing.
You just said graphing, right? Because I didn't see the O and then you got
Yeah. Sorry, I got terrible.
Okay, so our question is 36x squared minus 49, and you take the square root of 36 and you get 6. And you do that for both problems because there's also an x squared right there, so that's why there's an x. And then the square root of 49, and you get a 7, and then negative 7 because there's a negative sign right there. And that's how you get your answer.
Nice. What type is it?
difference of squares.
Difference of squares.
Squares. Alright, very nicely done. Okay, next group. Camera on or off?
Leave it on.
Leave it on. Here we go.
Alright. Here we go.
Remember when I did my 8s like that?
Okay, so this is our problem. And that was our answer.
Okay. What type is it?
Sum of cubes.
Cube. Sum of cubes. Good.
So we took the cube root of 8x to the third and we got 2x, and then we took the cube root of 125 and got 5. And then for the signs we had the same and then opposite and then positive. And then we got we did 2x squared and then we got 4x squared, and then we got 25 by taking 5 squared, and then we multiplied these two and got 10x.
Alright. Nicely done. Last group. Camera on or off?
I don't care.
Staying on. Here we go. This will be our last one. Perfect.
There's some pretty cool shoes.
Yeah, no matter how hard it is. So, this is my problem. And this was my answer.
Why?
So it's not a difference of squares because there's a plus sign there. You can't factor out any common factor. It's not a trinomial. There's no cube roots in it. And there's not 4 different
Grouping method.
yeah, you can't group it, so it's non-factorable.
There you go. Boom. Nicely done. Boom. Alright, good work everyone. Hopefully if you didn't yesterday, turn in your page 53 that was due yesterday in case you're on. Make sure that gets turned in. And thank you for all the groups that presented, very nice, very nice done. Monday, we're gonna practice a little more. We're gonna try more grouping method Monday, because I tried to pick problems you didn't have grouping today, because we need to practice that a little more. Okay, so thank you for all the work you guys did today. We'll be ready to go. Good luck to the football team tonight. Volleyball has tournaments this weekend. I don't, Jade does, sorry.
At home.
At home, so, good luck to them.
Chess club tournament this weekend?
What is?
Chess club tournament?
Chess club? No.
Well, we can make one. Dang it.
You can make one, go right in the middle like Garner, go right in Central Park,
Right.
play some chess against
Yeah.
the whole.
I don't have a chessboard, but if anyone does, I can bring it.
That'd actually be really cool to have